Hi, I'm Paul. This is Polymath. Welcome to the channel. Today I'm going to do 3 integration exam questions. Bam, bam, bam. Cover slightly different types of integration to get you well prepped for your A-levels. Let's get started immediately. First question. Given that k is a positive integer, z plus, show that something is independent of k and some other thing is inversely proportional to k. Let's do A first. Let me write it out. And the first thing I notice while I'm doing that is the difference between the two integrals we're being asked to do in part A and part B. One of them's got squared on the bottom, one of them's not got squared on the bottom. And basically, when there's no square on the bottom, in fact, only in that specific circumstance where there is something involving only an x and not an x squared, not an x cubed, nothing else, that is when, that and only then, is when your integral goes to something along the lines of 2 ln of the thing on the bottom. Just need to have a quick check if we need to make any corrections here. 2 just stays at the front. You've got a 3 in your ln. So if you did chain rule and differentiated it, you'd pick up an extra multiple of 3. So I'm going to have to divide by 3 here. 2/3 ln of 3x minus k. That is the integral. I'll do a recap after. Let's keep going with it for now. Plug in the numbers in. Two-thirds ln of, what are we saying? Well, I'll do a little bit of, no, it's going to do excess working, but you know what? No, I'm going absolutely wild and putting a 3k in. If 3 times 3k is 9, minus a k is 8k, minus, when we put the k in, you'll get 2/3 ln, 3k minus 1 is 2k. Wild. Now, why don't we just use our log rules? Usually you need to be careful about doing this when there's a number at the front, but both the numbers at the front are the same, so should be okay with that. Could take out a common factor of 2/3 to be safe. Using our log rule, that 2 things subtracted is like dividing it inside the log. K's cancel, 8/2 is 4, and you get 2/3 ln 4. Show that that's independent of k. Well, are there any k's left? Do you see any k's? Do your family members see any k's? There's no k's, so that is independent of k. They cancelled in that second last line. Let's keep going, and we can compare it to part B, because in part B, as I said, it's got squared on the bottom. That's almost the more normal thing. What do I mean by normal? I mean that when you were first born and learned to do your first integral, about probably 2 to 3 weeks after birth, you would have been told to deal with things like this. Well, look, I'm putting that in the top with a minus power, right? If you square something, on the bottom, there's a top with a minus power. It's indices, isn't it? And it's dx, right? And the way you would have learned that as a young baby would be add 1 to the power and divide by the new power. Add 1 to the power, minus 1, and divide by the new power. Oh. Only other thing we have to do is take account of the 2 with the 2x. That also has to get divided. Simplifying it slightly. Cancel, whoosh. Minus 2x minus k to the minus 1. See what I mean? It's more of a conventional integration. Add 1 to the power and divide by the new power, and then deal with that 2 inside as well. The only time when you don't do that is when it's like in part A, when it's just something to do with an x on the bottom only without any squares or cubes, then it goes to ln. I'm banging on about it too much, haven't I? Let's just let's pick up the pace, get the job done on that. Well, that's minus 1 power is like 1 over. So that'll be like minus 1 over 3k, looks like, doesn't it? 2 times 2k is 4, and then, yeah, okay. Minus 1 over, if you put the k in there, you get 2k minus k is k. Multiplying out a little bit. What we're saying, times top and bottom by 3. Happy with that? And looks like you put all the puzzle pieces together then, 2 over 3k. Inversely proportional to k. It is inversely proportional to k. Inversely means the k is on the bottom. You learned that in GCSE and probably totally forgot it since then because it never actually comes up in the A-level syllabus particularly often. But that is inversely proportional to k. So that's our first question done. Next. Use the substitution x equals u squared plus 2 to show some sort of monstrosity of a thing happening, and then use algebra to do something a bit crazier. Substitution, the first thing I'm going to do when I hear about substitution is write it out and then differentiate it. If I differentiate that, we've got dx plus d, so dx by du is 2u. If I then do a little bit of rejiggery pokery, it's not too much required, dx in this case equals 2u du. All right, so now might as well change my bounds. Bit early, probably something I would normally do at the end, but you know what, I just quite fancy today getting the job done quick on that. So if I just write that over here somewhere, you got at the moment 10 and 5. If you plug 5 into x equals u squared plus 1, we might just want to rearrange that actually slightly. U is going to equal x minus 1 square root. That means 5. When you put that in, you got square root of 4 is 2, and square root of 9 is 3. There you go. So that's your new bounds, 2 and 3. Do you know what? If I actually put them in the right place, that would help. But, you know, you never know. You can't really get the staff these days. Done the bounds. 3 at the top. X minus 1, that's a bit weird. Let's have a quick look. Yeah, that's u squared. If you look about it, if you square this, that's going to be u squared. Just stick that there. Come on then. U squared. And that's x minus 1. And then you got that absolute monster. All right, well, it's going to be 3 plus 2 times. This time the square root of x minus 1, that's u. You can see that from the old, that thing there. So, all right. Then we change the dx to du per this. Here's one I made earlier type thing. And that'll give you 2u du. All right. And this is your first moment to really just take a step back, look at it and think, how good am I? You know, my self-confidence is through the roof. I've gotten rid of all my x's and I've changed them all to u's. What a great day. It's a success. My life has peaked. It's not quite in the form they want it though yet. I'm sure we could get there pretty quickly. 1u will cancel with the u squared at the bottom, and 2 times 3 is 6. Oh yeah, so it pretty much is in the form they want it. P is 2 and Q is 3. So, part B, hence using algebraic integration show somehow that ends up ln A. Whoa. Quite common to get something like this in an exam when there's like a 2-part situation with 2 different types of integration going on. All right, we've done substitution. It's left us here. You'd think that should be easier to solve. You know, you'd think the substitution. I'll tell you what I'm looking for. There's a u. There's a 3 plus 2u. It's a factorized quadratic type looking thing. Partial fractions. I know it's got a u there, so it's harder to spot it, but it's partial fractions. So let's get the partial fractions sorted then. We're going to rewrite it. Let's do it maybe here actually. We're going to do 6 over u3 plus 2u has to somehow or another get written as partial fractions. Now, from your partial fractions after school club class that you go to where you do hours of this stuff, it's just partial fraction after partial fraction. That is the style a over u plus b over 3 plus 2u. And when you cross multiply, that's going to look something like 6 equals a times 3 plus 2u plus b times u. Then you're going to sub in some stuff. Probably going to sub in u equals 0 first. So 6 equals 3a, a equals 2 at a glance. And then you might think about subbing in who knows what. U equals minus 3 over 2, I would have thought. You think so? You put that in there, that should make that 0, shouldn't it? Yep. And then you'll just be left with 6. You'll be left with 6 equals minus 3 over 2b. So many would allege in that scenario that b is going to equal minus 4. You get 12 divided by minus 3. So, with all that said and done, our integral is going to change to between 2 and 3 of 2 over u minus 4 over 3 plus 2u du. So you're set with your partial fractions. You're going to integrate this now. The first one is hopefully fine. That just goes to 2 ln u. The second one, we just did it in the other question or something very like it. That's going to go to 4 ln 3 plus 2u, but you've got to divide by that 2 inside for the same reason as last time, between 3 and 2. Subbing our stuff in, 2 ln 3 minus 2 ln 9 actually, if I'm not mistaken, then minus 2 ln 2 minus 2 ln 7. Let's keep going. Do you know what? Let's use our little log rules here first. Sorry, I shouldn't call them little log rules. That's actually quite demeaning. Our grand log rules. You're going to get that because subtract. You can divide when it's subtracting. And here, same thing again, right? 2 ln 2 over 7. Looks good. And again, you can just do the same thing, actually. That's going to go to, well, tell you what, let's put the 2's up the top, because if you look at the final answer there, it just wants it as ln A with no number at the front. So if you, let's do it, put 2 at the top, it's like squared, ln 7, squared. So that's really ln of 9 over 81 minus ln of 4 over 49. And again, 9 over 81 divided by 4 over 49. I think that's probably a time to go for the calculator. Would you agree? What do you think? What do you actually think about that? 9 divided by 81 divided by 4 over 49, 49 over 36. Let's do a quick turbo recap of that one. It's had some funky moments. Part A, it said use substitution. If it says use substitution, first thing I do is differentiate the substitution. Then rearrange it to make it dx equals, that was dx equals 2u du by, 2u du. I could sub it in. Then I changed the bounds and pieced everything together to change all the x's into u's. Did that, ended up with this line of working, which is what they were after. Now, part B. Doesn't tell you how to do it. You've got to have faith. Denominator is a factorized quadratic. Harder to spot when it's u, perhaps. Your brain needs to be trained, but it's partial fractions. Dust off your partial fraction skills. When you do it, it should look like this with the 2 and the 4. and you're off, because both of those are line integrals, like in the first question. There's no squareds down here, there's no cubes. It's just things with a u to the power 1. They go to line. Make sure you divide by that 2 in the second one, and then you're off. Subbing in and using your log skills, you know, your log rules. I don't know how good you are at log rules. Have you practiced them? Did you practice them yesterday? A week ago? A month ago? Never. You may wish to do so. If you've got an A-level, you know, if you've got an exam coming up, do consider doing so. Do consider it. Final question. Figure 2 shows a sketch of some sort of part of a curve. There seem to be a couple of e's going on there. Apparently the curve is y equals x ln x. X is bigger than 0. All right. The line L is a normal at that point. And they want us to, I think, eventually find that region. Good question. Typical of something you're going to get in the exam. Let's get a strategy in place first of all. I'm going to just quickly resketch it. And if it's this area that they're wanting, you might be wondering what to do. I'm sure you will be wondering what to do. People do find this hard sometimes. Look at it, stare at it. Think, what does integration give you? Integration gives you area under the curve. Integrating from all the way from here to here is not going to work. It's going to give you too much area. It's going to give you all of that. But we do need to get some integration and some not. So I'm just going to tell you, after you've stared at it for long enough, the trick is to draw a line down here. And in fact, we do know the x-coordinate of that is E. Not sure what this is yet. Let's call it x1. There's a triangle. So strategy-wise, thanks for joining me in the strategy meeting, because strategy-wise, to find the overall area, what we can now do is integrate between x1 and E of the graph, which is x ln x. And then we can add on the area of that triangle. That is the strategy meeting convened. You know, you've got to get that. You can be the world's leading expert at the 53 different integration methods, but if you can't piece together the right areas on the graph, you know, you're going to get sacked from your you're going to get sacked from the board of directors. So now that we've got the strategy meeting, and by the way, we also know the y coordinate here is E. Let's get going to find all the other points that we need. Let's deal with this triangle first, I reckon. With that triangle, we really need this coordinate here. That's where the normal cuts the x-axis. We're going to have to find the equation of the normal, and then where that cuts the x-axis. Equation of a normal is differentiation. So I'm looking at this, I'm thinking how to differentiate it. You've got your three main rules: product rule, quotient rule, and chain rule. Quotient is if it's dividing. There's no dividing here. Chain rule is function inside another function. Again, not here. This is product rule. There's two things multiplied. Product rule, shall I write it out? If you call that u and you call that v, it's du by dx times v plus u times dv by dx. In other words, differentiate the first thing, 1 times the second thing not differentiated, plus the first thing not differentiated times derivative of ln x is 1 over x. So that will simplify to ln x plus 1. Cool. That means the gradient of the tangent at x equals e is ln e plus 1. Ln e is 1, so you've got a 1 plus 1, which is 2. We don't want the tangent, we want the normal. So you've got your old m1 times m2 equals minus 1 festivities from back in GCSE. And so your, gradient of the normal, which is m2, will be minus a half. Y equals mx plus c. y equals minus a half x plus c. And you've got a point on the graph there, it's EE. Now, I'm not sponsored by any phone companies or networks. So plugging in EE, E equals minus a half E plus C. So that means C is actually 3 over 2 E. And, you know, this is what they're like in the exam. They come up with some pretty interesting equations involving, you know, E, no less. All right, that is the equation of our normal. Now, where does it cut the x-axis? That's when y equals 0. So why don't we say equals 0 cuts x-axis. Cuts x-axis. And solving that looks like it's going to give x equals 3e. Going back up to our little picture here, that's now 3e. That was e. Half base times height. Half times, now the base is 2e, and the height is e. 2's cancel, e squared. Area of the blooming triangle is e squared. I'm just choking on something, but that's fine. I don't mind if I choke because we got it right. I've got to do this integral now. And actually, before we do so, we've got to find the x1. Well, that's when the curve equals 0. Let me just write this here. 0 equals x ln x. Two things multiplied equals 0. You've got two options. Either x equals 0 or ln x equals 0. All right, interesting. Well, looking at the picture, there's where x equals 0. That checks out. And if ln x equals 0, either you can do e to the power of both sides to undo it or whatever you want, but that happens when x equals 1. Ln of 1 is 0. Da, 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 da. All right. So let's change that. That's 1. Here as well, it's now 1. That's quite nice. Look at that. Got all those x coordinates now. 0, 1, e, and 3e. What a happy family. Great. I'm sure they go on some great holidays together to Torremolinos. Okay. Integrating between 1 and e, x ln x. We have done partial fractions today. We have done substitution. And now this one is parts. We just said when we're differentiating things multiplied, use product rule. Or when you're integrating two things multiplied, it's more often than not, is parts. So for parts, usually you would call the thing with the x u, and the thing that doesn't have an x, dv by dx. However, everything changes when there's a ln involved. When there's a ln involved, you better bet your bottom dollar or, you know, your brother's bottom dollar. I don't care if you don't have a brother. Go and find one immediately, because you're going to bet their bottom dollar that it's swapped, and that is u, and this is dv by dx. There's no deep real meaning for that. It's just it works that way. If you do it the other way, it's not going to work. Formula-wise, you've got that it's u times v minus the integral of du by dx times v. That's the integration by parts formula. So using that, you're going to have ln x is your u times. Now it's v you want. That means you've got to integrate your x. It will go to half x squared minus here, integral of, well, du by dx, derivative of ln is 1 over x, and your v is not x as I've written there, but it's actually half x squared. That's better. Cool. Let's do a little line tidying that up. Maybe put my bounds in as well while I'm at it. Oh, in fact, let's not put our bounds in yet. Do it in the next line. Totally backtrack on that. Ln x minus the integral of, let's put the half out here, and you just get x. Cool, and so when you do it, it's actually quite pathetic, really, isn't it? So I don't like to insult them, but it's actually embarrassingly easy in the end to do that part of the integral inside the integration by parts. It's just a quarter x squared. Let's stay humble though. Let's not laugh at the maths because it'll come back to bite us. Now putting the stuff in, a half e squared. Something to mention here is they've got an anti-calculator nuclear deterrent where they want you to leave it. If you look at that, it says show the exact area is ae squared plus b. You know, that is basically a nuclear submarine of a war missile looking for destruction of all calculators within a 6-mile radius. Because you're going to get decimal if you put that in your calculator, and it's not going to give you in that form. So brain power required. By the way, if I put it in, ln of e is 1. So I'm not going to write it. That just goes to half x squared minus a quarter e squared. Now when I put in 1, ln 1 is 0. Don't even bother writing it. Well, I mean, I will. And then you've got a quarter x squared. There you go. Half minus a quarter actually is a quarter. Yeah. And then when you put in, oh, why did I put another x squared there? Reasons best known to myself. That should just been a 1 squared, which is 1. That's a quarter. Yeah. So there we go. All good. Looks like plus our e squared from earlier with the triangoli gives us a grand total of 5 over 4 e squared plus a quarter. Quick turbo recap of that. They gave us a picture. They want us to find the area. The graph is x ln x. There's a normal involved. It's a multi-part exam question. You've got options what you do first. I like the idea of the derivative first. You differentiate x ln x. That's product rule because it's two things multiplied. It gives you ln x plus 1. Play around for a little while and you'll get the equation of the normal as being y equals minus half x plus 3 over 2e. That gets you the x coordinate, where that cuts the x-axis. Meanwhile, you found where the curve cuts the x-axis is x equals 1. And somewhere along the way, you've also come up with a correct understanding of how to find this area, is splitting it into a triangle and an integral. Triangle is e squared. The integral, we had to do integration by parts. Wasn't the worst one anyone's had to do, you know, since the dawn of man. The only thing to be careful for is whenever there's a ln x, that's the thing that's a u. Do it, do it, do it. Leave your calculator at home, put the e's in, and add your stuff together. Okay, thanks very much for watching, guys. Stay tuned for more tough exam questions soon. Have a lovely mathematical day.